I'll be starting the session now. So we are doing the webinar is about the preventive maintenance in the steel plant. I am Saptrishi Chaudhary and I'm working as a sales and application engineer in Manglam Electricals. So thank you everybody for joining this webinar. So talking about Manglam, we are having 45 odd years of experience in the metal and mining industries, and we are one of the leading knowledge-based solution provider in India. With innovative team members, we definitely pioneer excellence in non-contact temperature measurement solution. With Optris, we are into temperature measurement sensor solution. With Joanne's Hubnegiesen Lika, we are into encoders as well as FSG. So we are into encoders with them. Proxitron, we're into proximity sensors, object detection, I would say rather. With OndoSense, we are into level monitoring, distance monitoring, radar sensors. Motrona, we're into controller display. Video systems, we're into AI camera systems. And Animaturo, we are giving the conduits, uh, be it high temperature conduits, SS conduits. So our German partner Optris was founded back on 2003, and they are having a product variants of more than 3,000, I would say, and definitely 60,000 plus IR thermometers and cameras are manufactured from their factories per year. Before diving deep into the topic, I would just really try to focus upon why should we use the predictive maintenance, because most of the critical failures that starts with abnormal heat rise, the ref just a second. Yeah, the refractory thinning, bearing damage, DSL overheating, that these all starts with a hotspot that remain most of the times that remain unnoticed by the operators, because traditionally we use thermal guns that are the point sensors, but often we see that the point sensors miss detecting the problem developing zone. That can be minimized using a thermal imaging camera. In that case, we will be scanning the entire field of view that comes in its path, and then out of the entire field of view, we can point out the critical zones or the hotspots that are produced in that FOV. So as we see, late detection is equals to safety risk, asset damage, and breakdown. How often we see ladles getting the refractory getting damaged, and for that we have to that breakdown happens, and that also incurs the safety of the personnel that are involved in the process. So with our camera and solutions, we are detecting the hotspots early, and that helps us in planned intervention. Yeah, the data in front of us, we have collected it via, sorry. Yeah. So this was the global survey that was conducted by Sapio Research and commissioned by ABB. And it was head by Mr. Amit Gupta, the president in Motion Service Division. The survey includes 3,215 plants. So out here we can see really interesting records. 88% of industrial plants experience unplanned outages, and that cost, yeah, 7 million per hour, 7 million of Indian rupees per year per hour of downtime. And this can be significantly reduced, the cost can be significantly reduced by 25 to 40% using the predictive maintenance. But still we witness out of that 88% of industrial plants, 19% from still depends upon run to fail approach. I believe that the participants in this webinar should not be doing that, and instead we should be focusing upon the predictive maintenance. And advanced monitoring and conditioning increases equipment availability by 10 to 20%. So yes, I would really emphasis on the point that the predictive maintenance helps the plant prevent downtime, then additional cost that are being incurred due to this unplanned shutdowns. So for this we are having three different segments of IR camera, I would say. Firstly, we are having high resolution thermal imager. As we are saying, high resolution, it's offering us 640 by 480 pixels with a thermal sensitivity of 40 millikelvin, which is really good to capture a wide area, I would say. Then, of course, we are also having this mid-resolution camera with supply as power over Ethernet and the motorized focus. And finally, we are having this AI spot finder camera. Sometimes we witness that maintaining a separate PC for a camera is quite hectic for the operators. So in that situation, this camera will go standalone mode, supplying you the analog and the digital configurations. Even we can take it to different communications, be it Profinet, Ethercat, etc. So this works in autonomous mode without using the computer at a very high rate of 50 hertz. So its response time, I would say 20 milliseconds, which is quite good as compared to other thermal imaging camera that are available in the market. And additional feature being its autonomous operation. So do we have any question regarding this three sets division of camera? I would be happy to address any of them.
Hello,
Yeah,
myself Bhagrishri. I have a question regarding the third camera which you have explained,
right.
where you have said this will be autonomous operation. So
Autonomous, right.
my question is how we are able to see the hotspot in that. As you have mentioned, there is no requirement of a PC in this camera. So how we able to detect the hotspot? How we able to see the hotspot by the camera itself only, or anything else is
I, I,
needed?
I would say no. I would say PC for if you're willing to view the thermal image, then PC is obviously required. But some operator wants that I do not want the PC. I just want the analog output that comes corresponding to the hotspot. So that you can do without PC. If you want to localize the hotspot, if you want to locate the hotspot where it is out of the field of view, then you should have to have a PC. Just
Okay.
if you want the temperature corresponding to that, just a
For
minute. Yeah,
values, we can have we don't require any PC. If you want to see the values, the hot spots on the screen, then we require the screen PC. Okay.
right. So as you can see out here, the computer interface, we have mark one area for area one and the hotspot, the second one. So corresponding to these two areas, we are getting the analog output. Supposedly, maintaining a computer is not possible for the for the operator, so he can exclude this PC. Only the temperature will come in his PLC via the analog outputs. So this works as an autonomous operation. Yeah, was I clear or
Yes, yes.
okay? Yes. Any more question? I believe not. So we will be diving deep into the real world case study that will make the image more better for us. Yeah. So firstly, online monitoring
Sorry,
condition.
this Subramaniam, I got a question.
Good evening,
Is
sir.
your cameras only monitors, or it will give some calculation on background with the help of AI and it will give the result, or it will just display the
So
temperature
I
only?
would no. So I would say our camera has got two ports emerging out from it. The first one will give you the thermal image, and the second one will give you outputs. We are having output card with compatible with the camera. It will give you up to 9 analog and digital outputs corresponding to each areas. So if you are willing to have an alarm out of it, so you can have it via our digital
I'm
output.
not talking about analog inputs. I'm talking about, does your software have any artificial intelligence to
Mhm.
calculate all the temperatures based on that area? It will give the hotspot and how it is emerging that hotspot and what is the location like that.
So Consider, sorry, so consider as I spoke before, so consider there are 382 by 288 pixels in this entire field of view. So our hotspot detector will locate itself to the maximum pixel that has recorded the temperature, the maximum possible temperature that is recorded in the pixel. It will locate itself to the to that pixel and will give you the corresponding temperature out of it. And that temperature, if you are willing to have it physically, then you can program an analog output. And if you are willing to set a DO above any threshold, you can do as that as well.
Okay,
Subramaniam sir.
I think you didn't get my question. Does your camera have any artificial intelligence program? Means that
Hmm.
camera's image is image will be means detected and it is analyzed by some program and it will give the output. Does you have that facility in your
Yeah, this is the artificial intelligence only, the which is working behind the hotspot. Can you can you can you
it's a simply an image camera whatever you are
Hmm.
showing.
Hmm.
Yeah, it is an image camera.
Hmm.
It's not on artificial intelligence based camera.
So after we are giving that DO, you can do anything with it. You can
No,
keep
no,
it
no,
as
no,
an
no. Yeah,
interlock.
that's okay. That's the other thing. We can
Hmm.
put the program and we can do some calculations and we
Hmm.
can give the output.
Hmm.
So it means you doesn't have that program.
So
You are not
can
offering
you
this.
can you say your elaborate your application
Yeah,
for which application?
I'll give you an example. There is a
Mm-hmm.
company called Repic.ai. Okay, you heard
Okay.
about it. They'll give the cameras. They'll
Mm-hmm.
monitor all the means we have got submerged arc furnace here. It is a shell completely,
Mm-hmm.
the 10-meter diameter
Mm-hmm.
shell. You can
Right.
place the 6 to 7 cameras, or maybe in 120 degrees apart 3 cameras. You
Mm-hmm.
can combine the images of all the cameras. It will
Mm-hmm.
give using an artificial intelligence program. It will give the output and it will give the hotspots in the entire shell region.
Hmm.
But your camera will focus on the only one point where we'll get the hotspot. It's
No,
not
no,
a
no,
360
no,
degree.
no, no. The hotspot will position itself into the entire field of view that we are that we're capturing. It is
Yeah,
not. It
it's
is a dynamic
the program
positioning
will give
system.
that program will give an 360 degrees image and it will show that at hotspots areas.
It will only give you the image the camera can look into. For
Okay.
360-degree, you have to position four cameras out of it, and the four cameras can be merged into a single PC, and out of that will be getting the hotspot as you are telling. The similar way it works. The hotspot is dynamically positioned.
Okay, you can continue.
So the first application will be our the Tundish outer shell monitoring
Sir,
that
which
we did.
application for kiln shell temperature, which camera is suitable?
For kin shell monitoring, I previously that I said the high resolution one. Just coming to your application, just a minute. Yeah, the kin shell monitoring, we are using this high resolution camera that can capture up to a length of 104 meters at a distance of 30 meter from the kin if the camera is positioned itself. And with the ultra wide lens, we are covering the maximum coverage of the kin length, and we have got a
Our is
high.
the 110 meter.
Pardon, sir.
Our kiln is 110 meter length.
So in that case, I believe 35 meters will do it. Are you having sufficient place to position your camera?
Okay.
But this, if you're having space constraints, then we will propose you two cameras to be placed at some distance that it will cover fully. If you're having the space constraints with single camera, 30-meter distance, the single pixel size would be 163 mm. So 16 centimeter will be something, yeah. 110 at 32 meters we can cover 111 meters of length. And as this is a high resolution camera, we're also getting the pixel size smaller. So may I know your name, sir?
My name is Praveen Mahakalkar.
Just a minute. And sir, from which organization you are from?
Rashmi Group,
Okay,
Kharagpur.
okay, okay. I reckon we had a discussion, right?
Yes, yes.
Right. Okay. So any more question you're having with this one? Can outer monitoring? Hello,
No,
Mr. Praveen.
no.
Okay. So we'll get back to the Tundish outer shell monitoring. Yeah. So with this, we are getting the challenges where temperature not scanned throughout the shell, and as a result, the localized hotspots remains unnoticed. So for that, we have installed our camera at the shroud manipulator platform region, which covers the one part of the tundish. And as we can see here, the conventional handheld gun, it totally depends upon the operator where he basically points it. Out here, this he points it out here, so he's recording 175 degrees Celsius. But the original hotspot was somewhere else, and it noted 186.5 degrees Celsius. So it always depends upon how your operator is handling it. So this, the hotspot detector with our system, we are having the hotspot detector that scans the entire tundish, and the region of interest is continuously monitored. And we can also get an alarm if the temperature condition breaches. Just I'd be elaborating our functionality of the camera. So as I was saying previously, our camera has got two ports emerging from it, one for the thermal image and the other for the output or any kind of interface, be it Profinet, be it Ethercat, any kind of interface. So we are combining two cameras by a LAN switch, and that into a single PC. Up to 4 5 cameras we can do, depending upon the resolution of the camera and the PC configuration. So inside JB, we are giving the switchgear units, most importantly MCBs and fuse, SMPS, the output card, of course, and the gigabit servers. Sir, do you have any question regarding this topology, connection topology? I'd be happy to help you in this. So for this Tundish monitoring, we would be requiring two cameras to view it from the backside. And the operator side, I haven't gave any camera because the operators are continuously monitoring whether the refractory is getting red hot or not. So else you can obviously have one camera for the entire front side of the Tundish. So I believe I should move forward. Yeah. Moving to our next application, this is the online monitoring of the EMF bottom shell. The major challenge is human. It is mostly that is inaccessible to human reach. So out here we are having this thermal camera installed for the bottom shell monitoring that monitors it 24/7 with no manpower. Scans the full bottom shell, and if the zone temperature breaches, an alarm is also generated. A visual alarm can also be generated. Supposedly, this hotspot, if goes beyond 600 degrees Celsius, then it will turn red. The color coding is also available with our software. Any question for this application, or anyone with a similar application problem? So our next application is the vessel outer shell monitoring. We did the bottom shell monitoring. Outer refractory lining also degrades and crack forms over time. With unnoticed hotspot lead to acid damage. Here also we are giving the real-time temperature monitoring with early hotspot detection. Yeah, we are having this. We just a minute. we are having this video out here. We have excluded this part because this will naturally be greater temperature in all the time due to the vapors and high hot vapors. So this was one of the application that we have successfully completed. Uh, just giving you some of the insights of the site. We have placed this camera at approximately 20 meters from the converter shell, and we have got a good coverage of 25.5 meters by 16.6 meters with a single pixel size of 40 mm, I would say. And we are also proposing this outdoor protective housing for the enclosure of our camera. So anybody with any questions?
Sir, can you provide a blast furnace camera?
Pardon, sir?
Can you provide a blast furnace camera?
Blast furnace, I believe, for monitoring 2 years or for hello.
My voice is audible.
Yeah, your voice is audible. I was telling for which application you are willing to
Uh,
uh,
blast
yeah.
furnace, blast furnace.
Yeah, blast
Blast
furnace.
furnace
In
inside a
blast furnace.
temperature is showing, yeah, imagining, showing view.
So 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 for refractory if you are placing the camera out, means for what temperature? Molten metal
Inside.
temperature,
Metal is charging in a BF, and
right?
all view is showing in camera.
Yeah, we can propose you a molten metal monitoring camera in that case. So sir, may I know from which organization you are?
Welspun,
Hello.
metallic ganjar.
Wellspun, okay. I was in touch with one of your official, Mr. Ashutosh ji. Yeah, for definitely for monitoring the molten metal temperature, we are also having the cameras, thermal imaging camera.
How can you use in other areas ladle temperature?
For that we have to install the cameras from the upper portion, by which it will be able to see the inside molten metal temperature. For ladle you're talking, or for the
I think
this.
bottom temperature. Is it?
Hmm.
Uh, My we need in a bottom temperature in ladle.
Yeah, so for that we can be positioning our camera similar to this application. So the bottom will be continuously monitored of it. For ladle, I would be, yeah. So this was a ladle application. So out here we have positioned four cameras from four side, and if you are willing to have the bottom temperature of the ladle, so we can place it from the bottom as well. In that case, you can have the clear view of the ladle bottom, and with any hotspot emerging, that one, it will also be notified to you. So yes, we can perform this application. Sir, may I know your good name, sir?
My name is Sukumar Yogi.
Acha, Ashok. Yeah, definitely we can monitor the ladle temperature as well as the
We
blast
can
furnace water.
exercise and we can give an offer. How
Pardon,
can
sir?
you use an ladle camera?
Hello.
Yes, yes. Audible, my
Yeah, your voice is audible. Yes, sir.
okay, okay.
Your voice, I believe, is cracking. You can please try again, sir. Hello, Mr. Ashok Kumar.
You,
Hello.
My requirement is you understand, sir?
Yeah, I understood your requirement. You are looking for the monitoring of the ladle bottom shell. So
Yes,
yes.
sir. First blast furnace camera. Um,
Blast furnace
is
molten
we
metal
are watching
monitoring.
in inside temperatures.
Sir, are you currently using any kind of sensor for this? For blast furnace molten metal monitoring?
Uh, top area is installed in BF top area installed in camera. Reactive.
Okay, so any problem you are facing with the existing setup?
Okay,
Hello,
okay. You can
hello.
plan and visit and
So
that
what we will do, sir?
site.
We Yeah, definitely we can plan. Sir, your plant location, I believe it is in Gujarat, right?
Thanks for Madana Punjab, Gujarat.
Gujarat. Okay, we can talk on it, sir. Yeah. Any more question for this ladle monitoring?
Okay, sir. Okay, can we start, sir, again? Yeah.
Okay. So we are doing a 360-degree monitoring of ladle from four sides, with our camera position at four different locations, and all the four images can be processed in a single PC. So this, so any more questions regarding this? Anybody ladle monitoring? So moving on to our next slide. I would say monitoring the LF transformer bushing is also quite critical, because at the room, no personnel is allowed to enter. No manual entry is allowed during the arcing time to check the bushing temperatures. So for this, our camera can be quite handy. So you can see we have placed our camera at a distance, and we are monitoring the two bushings, and we are getting the analog and the digital output for each of the bushing. And this is a real-time temperature measurement of multiple region of interest. So with minimal human intervention, we are covering most of the applications. So for this, I would say this thermal imaging camera would be an ideal solution, because again, manual entry is not allowed during the arcing period. So for this, we are using this mid resolution camera. And so any question regard any applications similar to this one? If anybody is having, then he can share it. So let us move to the next. Yeah, online condition monitoring of ladle on crane. So again, we can see out here the refractory that has over time, the refractory lining degrades, and that may develop crack. So at this time, when the ladle is on the crane, it is really critical. If some degradation on the refractory lining happens, then it can cause a huge accident. So for this, we need to really measure monitor the outer shell of the ladle. Reliable alarms at set threshold. So as I said before, we are having all the color codings. Beyond the threshold, we can give it red, and if it is below the threshold, then we can give it any color, be it green or blue. And the auto hotspot tracker, as I said, it positions itself to the worst refractory part of it. And most importantly, early detection for selective repairs, and it improves the ladle life. Yes, sir. So any question regarding this?
Camera is rotation 360 degrees.
Pardon, sir?
This is a camera is rotation of 360 degree.
No. This camera doesn't rotate. You need, for 360 monitoring, you need to place four cameras from four sides. This camera is stationary. You need to place four cameras from four sides.
Okay, sir. Okay. Right.
Right. Again, the DSL bus bar is also a critical application. The collector terminals remains unnoticed, and no real-time DSL monitoring leads to the delayed default detection. So for this, for this, we are giving cameras with 9 digital and analog outputs. The system, just a minute. Yeah. The system automatically shoots a snapshot of the overheated zone while the crane is moving, and any part, any overheated part comes under its surveillance. It automatically takes the snapshot of the affected area and stores in it for postmortem analysis. And we're also giving this water cooling as well as the air purge, called air purge laminar, to safeguard the camera from the adverse situation. So yes, this application is also important
Yeah.
as.
The DSL camera is only visible and only temperature.
Yeah, so this I would say for this there was an accident upon. After that we were called. The current collector terminals that are present in the DSL bus bars, that need to be monitored. That gets overheated, and at the same time it's the sparks happen. So at the we are placing our camera at the crane, and as the crane moves, the camera is exposed to all other current terminals, and as no sooner did any current collector terminal reaches its temperature, it takes the snapshot as well as also gives the analog and digital output correspondingly. So in this way we are so providing solution for this application. So any question regarding this? Any question, or should I move forward? The next application is the carbon brush monitoring of DC motors. So nowadays, I believe that most of the mill motors are AC, but there still exists some of the DC motors. For that, the carbon brush and the commutator gets damaged due to overheating. So for this, we have thermal cameras that detects the overshooting of temperature of the carbon brush as well as the commutators. And we are having, as it is a thermal camera, so we can have online streaming of it as well. The snapshot is also triggered if the if the temperature exceeds for spark or some short circuit or insulation failure. So everything can be recorded by our thermal imaging cameras. So any similar application we are having, or any similar problem that occurred and you are looking for some solution, so we are having this application also in our table. Okay, so I'm moving to the next application. This was the kin outer shell monitoring. As the challenges exist, cracks get generated due to unidentified and localized hotspots. So we are providing a thermal imaging camera that does the thermography of the entire kin outer body. The auto hotspot tracker identifies the localized hotspot, and of course we are having this color changing facility of our system that gives the visual alarm, that acts as a visual alarm and points us where actually the temperature is overshooting and the refractory is deteriorating. So for this, essentially we require this high resolution camera because we have to cover a wide area, and if we have to cover a wide area, then we need multiple number of pixels for covering the smallest part. And also we are having this low thermal sensitivity of the camera, 40 millikelvin, that detects the smallest possible deviation. So any more kin monitoring application? We were having Mr. Praveen from Rashmi. Any more for this skin monitoring application, or any
Can we
question?
measure the inside temperature also? Can we see the inside view of kiln?
So for inside, I would say you have to pierce a hole into the kin. The camera only views whatever it is matlab, readily available with it. So if you are willing to have an inside view, you have to pierce a hole into the
No,
skin.
we
So
have from outlet, kiln outlet,
hmm.
we can see all.
No, so inside temperature I cannot give it to you.
No, no.
So may I still know your good name and from which organization you are from?
Myself, Praveen Mahakalkar.
Okay. No, sir. Inside I cannot give you, but obviously the outer shell can be monitored using thermal camera. So for the time being, what sensor you're using for inside temperature monitoring?
We are using thermocouples.
Thermocouples, right? So contact types are only available for
But
inside monitoring. You cannot do it from non-contact basis.
yeah,
So shall we move to our next application?
yes.
Next, we're having this switchyard application where unmonitored, they are in bus bar we are having minimal number of current collectors, but in switchyard the number of current collectors gets multiplied, and and there is also potential safety hazards. For this we're also having camera. For this purpose also we should use the high resolution camera for getting the maximum amount of area coverage and getting the pixel as small as possible. And our camera is also operating at 70 degrees Celsius without cooling. So this feature essentially helps us of eliminating the additional accessory of water cooling. So this feature is also an important one with with the high temperature, high the that camera, high resolution camera.
Sir,
And
what if the temperature is higher than this mentioned range, which you have mentioned, 70 degrees Celsius?
70 degree. Okay, so I believe in ambient conditions, these are into the fields ambient condition. If seven from above 70 degree, you should have a water cooling jacket, but I don't think the temperature will reach beyond 70 degrees Celsius, because these are into the open fields where the switch yards are located into. And if any if you are putting it in any other application, then yeah, if 70-degree breaches, then you have to have a cooling jacket with it. Yeah.
Okay.
And the cooling jacket will boost the temperature up to 315 degrees Celsius, provided the correct supply of water temperature and pressure.
So what about the water supply? But from where it is getting? Do we have to put the tank
The,
to nearest to this place where the camera is
yeah, the
located?
water, yeah, the water that you are feeding in should be 30 degrees Celsius at a pressure of 1.5 bars, 1.5 liters per minute.
Again, the water which is cooled. Okay, the question is, do we have to maintain the particular mentioned temperature range, as you have mentioned, 30 degrees Celsius for the water? Do we have to maintain that particular temperature for the water itself?
Yeah,
And
we have. Yeah, please complete your question. Sorry.
pressure, as you have mentioned, 1.3 bar, what
Mm-hmm.
I have heard. So
Mm-hmm.
we have to, while using that particular application which you have mentioned,
Mm-hmm.
have to maintain the water at the particular 30-degree temperature and pressure also likewise.
The pressure is something that is important. 30 up to 30 degrees Celsius, we are telling the ambient will be 315. Of course, if the water is below 30 degrees Celsius, it is good, but it should not be above 30 degrees Celsius. If the water
Okay.
temperature is beyond 30 degree, the ambient also significantly reduces from 315. So it will start reducing, because that effectively the water cannot cool our camera in that case if it goes beyond 30 degrees Celsius.
So is there any system in your particular setup that it will monitor the incoming water supply to that cooling circuit of your camera?
So I would say we are having an internal temperature monitoring unit that will keep continuously that will keep continuously updating you that what is the current temperature that internally it is. Through the software only it is available. So we can tell you that what is the internal temperature of the camera.
Internal temperature, but the water it is coming the don't
No,
not the water
no,
temperature, but internal
no,
circuit
not the
temperature will be monitored in the
right.
camera itself. Okay.
Correspondingly, if you see the internal temperature is getting rise, that means on the contrary, the water temperature is also rising. For that, it is not effectively able to cool it. So in that case, you
This,
can check the water.
sir, this camera is showing inside temperature, oil temperature, bonding temperatures,
So this camera is also
as a
having
like.
Mhm. This
Sir,
temperature, this camera will also give you the internal temperature as well, along with the other temperature that it is getting in the field of view. It also gives you the internal temperature. What is the current status of the camera?
sir, already we are installed bonding temperature in RTD. Both are compared. Um, camera again already installed.
Sir,
Uh,
can you come again?
showing
Can you come again,
as
sir?
compared to temperature.
Hello, sir. Can you come again? Your voice was
My
not
voice is
audible.
audible, sir.
Yeah, yeah. You are now audible, sir.
Uh, Already transformer is installed both temperatures RTD.
Mm-hmm.
But extra protection is installed in camera.
Mm-hmm.
But as it compared to RTD and camera, the
Mm.
temperature, what is the difference?
Right.
What is the difference?
So yes, sir. Then
You understand, sir?
so you are comparing RTD temperature with camera temperature, right?
Yes, yes, yes. I
Okay.
got.
So I would say the camera is plus minus. I would say 1% in accuracy with the RTD. Hello.
Okay, so okay, sir.
The
But sir,
temperature.
some given an example is one ST panel is installed and taken a line and the 11 kV, 33 kV.
Hmm.
But I measure t- measure in temperature inside parts. The
Inside in
thermography is in not showing
Okay.
temperature uh,
So I would say
inside
for this
parts. But
application, yeah.
remove and inside uh, covers after get the
Hmm.
thermography is properly showing temperature. But the
Hmm.
camera,
Hmm. Hmm.
how can use in a camera? Internally part is it showing a temperature?
So So I would say, sir, for internal temperature is getting reflected on the outer surface. If you're capturing the outer temperature, it also shows you some bit of the internal temperature. If the internal temperature overshoots, it will be reflected to the outer. We cannot directly check the internal temperature, but yes, we can check the outer temperature. For, as you said, if you are removing the covers, then the temperature of the internal surface can be accurately measured.
Okay.
Sir, your good name was Ashok Kumar, right?
Yes, yes. My name is Sukumari. I am
Right,
Sukumari
right, right.
only.
Right. So the other meeting that we will plan, we will address both of
Okay,
your
sir. Okay, sir.
application.
Definitely,
Mm-hmm.
I meet you. You can visit
Mm-hmm.
in plants,
Right. Okay.
plant in tour.
Okay. So with the camera, we are providing following accessories: the housing, as I mentioned, the cooling jacket, the air purge laminar. Conditions are there where there are much spatters. For instance, the bottom shell monitoring of the EAF, where much spatters splashes at the surroundings. So for the time being, the ladle is getting charged, we can have the shutter closed, and then after the spatters are over, then we can have the shutter off. So for this application, we are also providing the shutters, as well as the mounting accessories, the output cards, the junction box, the workstation. All of these comes under, we can take it under our scope of supply.
Sir,
And
my question is, if some existing plant is there, they
mm,
already have a system of thermal monitoring of the particular plant. So they
right.
already have a PC based system for their
Mm-hmm.
particular equipments where the requirement of thermal monitoring of a particular
Mm-hmm.
device. Okay, so
Okay.
your cameras, if particular plant owner buys the cameras, so
Mm-hmm.
do you integrate to their PC, or your requirement is to have your own PC?
No. PC is something that customer can take it in their scope, provided we will give them the necessary features, or the necessary software. We will provide them the necessary software in the pen drive. The computer
Oh,
should be compatible. We'll giving them the list of features that the computer should have, and if
okay.
it satisfies, then they can have their own PC, no issues. Yes. And if they are will not having any PC out there, and they are telling us to keep it in our scope, we can keep it in our scope as well. So PC
What
is something you
software,
can keep it.
again, the particular software which is required for your process, what the
Mm-hmm.
software name is, which has to be integrated? Again, the compatibility software will be others, which has
Mm.
to be there in the PC. Again, I'm talking about the software which is required for the process monitoring of the thermal uh, energy. So what the
Right.
particular software is required, which
The
has to be
particular
there?
software is Pix Connect that we will be giving them in their pen drive,
Okay.
and the computer should be that we'll give them the these things that are required, the prerequisites of the computer. So yes, then you can have it in your scope as well.
Okay, got your point.
So yes, I was talking about the three division of camera. If I were to give its technical specification difference, so I would say the first, all of the three cameras, the temperature are from 0 to 250. So these temperatures are switchable. You can switch at any point of time, that depending upon the application demands, from 0 to 250, from 20 to 900, and from 200 to 1500 degrees Celsius. All the three temperatures ranges are compatible with the high resolution as well as the mid resolution camera. The only difference in the AI spot finder is it is not having the third temperature range, but yes, it is compatible with the two temperature. This is auto selectable at any point of time. The optical resolution will be 640 by 480 for the highest one. For the mid, it reduced to 382 by 288 pixels, and finally to 80 by 80 pixels for the AI spot finder camera. All the cameras are compatible for the analog and the digital output. The frame rate is significantly high for this high resolution, 80 hertz for mid resolution, and finally 50 hertz, as I said before, is for the AI spot finder. All our cameras are IP rated highly IP rated of 67, and 70 degrees Celsius is what I was telling at the time of switch yard is for the high resolution camera, and the rest are 50 degrees Celsius rated. So any more specification that you are interested to know? Anyone? Any more specification that you are looking for? I have jotted down some of them, but if you are looking for any other specification, technical specification, I can give you, I can tell it to you.
Sir, if you able to add the power supply requirement of these cameras, as you have mentioned, mid-range will be required the PoE. So what is the power
The power
consumption?
supply, I would say, for all the cameras, it is 8236 VDC, and additionally for this mid-resolution and AI spot finder, they are also acting over Ethernet as well. Power over Ethernet is also available for this two segment of camera, but this one essentially requires a supply of 8236 volt DC.
Okay.
This is a camera used in other protection as like conveyors, belts.
For conveyors we propose, if you are willing to have the image, of course, the mid resolution camera. If you just want the temperature corresponding to the conveyor, then I would suggest this AI spot finder. With AI spot finder, you do not have to maintain a separate PC with this.
है ना है ना पेडेस्ट्रियन फैन बोला तो
So does it satisfies your question, Mr. Ashok Kumar?
okay sir I got it sir but
Hmm.
definitely second question is different metal are coming in conveyors how can I identify coke and penta dolomite as different metals are there in blast conversation
So for identification of different metal, I would say you to use
yeah
this mid resolution camera with computer compatibility. At any point of time, when the temperature breaches, it will take the snapshot, and after post mortem analysis can be done with it. So for that, you can use the camera with the PC. And if you're only interested about the temperature of the region, then this AI spot finder camera will be quite good for you.
I think I implement an project. Uh, how can tentative? Budget?
So
We need.
the budget is typically around 2.5 2 to 2.5 lakhs, depending upon the accessories you are taking for this AI spot finder. And for the mid resolution, I would say the budget will be somewhere hovering around 5 to 5.56 lakhs, depending upon the accessories you're opting for it.
So, particular dashboard.
Sir, may I know from which department you belong to? Hello.
I, I am
Sir,
Ashok Kumar
from
Yogi. I work I electrical instrument automation.
in blast furnace.
Yes, yes.
Blast furnace. So how many blast furnace are there for Wellspun?
Yes. Again, repetition.
I was telling how many
Yeah.
blast furnace are there in Wellspun?
Um, blast one blast furnace is available in
Okay, okay,
one blast.
okay. And sir, what is the end product?
Final product पे जा रहे हैं blast furnace is the final product पे जा रहे हैं
Sorry, sir.
final blast furnace product
No, no.
पे जा
I'm
रहे हैं
telling the final product of the plant. What you are
पे जा रहे
producing? Billet.
no 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 and Wellspun WDI final product is duct iron pipe but blast
Okay,
furnace
okay.
final
DI pipes.
product is
Okay,
the pig iron
okay.
and second product gas third is slacks
Mm-hmm.
three product are there in the blast furnace.
Okay. So any more question? Anybody? Yeah, so as I was talking before, we apart from this temperature monitoring, so we are also into speed, position, presence detection, distance level, artificial vision system, angle monitoring, as well as electronic components. So anyone with any other requirement can surely get in touch with us. With temperature, we're also into encoder systems, proximities, HMDs, light barriers, radar sensor, artificial vision system, potentiometer, inclinometer, and all the other electrical components, be it transistor, it capacitors, fuses, etc. As well as controller displays with conduits, I would say. So anyone with any question regarding the entire webinar session?